Good evening all, this is Indra from pantechelearning. Am I audible? Sam Daniel, good evening. Aarti, good evening. Sanjay, good evening. Ram Shankar, good evening. Rupika, good evening. Aishwarya, good evening. Ashwin Balaji, good evening. Venkat Reddy, good evening. Am I audible everyone? Deepshika, good evening. Am I audible? Yeah, good evening all. I warmly welcome you all to my session. Am I audible? Yeah, okay. Thank you for your response, Ashwin Balaji. Yeah, Harish Shah, thank you. So, shall we start the today's session? Are you all ready, shall we? So, in this session, we will see how to use the I2C LCD liquid crystal display with the ESP8266 using Arduino IDE. Moreover, I will show you how to wire the display, how to install the library, and we will try some sample code to write text on the LCD like static text and scroll long messages. So before getting into this, let me give an introduction about what is I2C. So here I2C combines the best features of SPI and UART. So with I2C you can connect multiple slaves to a single master like SPI, and also you can have multiple masters controlling single or multiple slaves. So this is really useful when you want to have more than one microcontroller logging data to a single memory card or displaying text to a single LCD. So like UART communication, I2C also uses only two wires to transmit data between devices. One is serial data and another one is serial clock line. So this data line is for the master and slave to send and receive data, and this is the line that carries the clock signal. So I2C is a serial communication protocol, so data is transferred bit by bit along a serial data line. Like SPI, I2C is a synchronous, so the output of bits is synchronized to the sampling of bits by a clock signal which is shared between the master and the slave. So the master always control the clock signal. Mukta, actually I don't know about the electric vehicle design class. If you have any queries regarding that class, in the sense you have to talk with that particular admin. So you can, if you have any mail IDs or number of them, in the sense you can just ask your queries to them. In my class, if you have any queries or doubt, in the sense you can ask me. I will answer all your questions. I will talk to the admin and I will let you know if you texted to them personally or not. And now let's see how I2C works. So with I2C, data is transferred in messages. So messages are broken up into frames of data. So each message has an address frame that contains the binary address of the slave and one or more data frames that contain the data being transmitted. So the message also includes start and stop condition, read and write bits, and also acknowledgement and non-acknowledgement bit between each data frame. So first, start condition. How to start this I2C? So the data line switches from a high voltage level to a low voltage level before the serial clock line switches from high to low. And stop condition, the serial data line switches from a low voltage level to a high voltage level after the serial clock line switches from low to high. And coming to address frame, a 7 or 10 bit sequence unique to each slave that identifies the slave when the master wants to talk to it. So I2C does not have slave select lines like SPI, so it needs another way to let the slave know that data is being sent to it and not another slave. It does this by addressing. So the address frame is always the first frame after the start bit in a new message. So the master sends the address of the slave it wants to communicate with to every slave connected to it. So each slave then compares the address sent from the master to its own address. If the address matches, it sends a low voltage acknowledgement bit back to the master. If the address doesn't match, the slave does nothing and the data line remains high. And coming to read and write bit, a single bit specifying whether the master is sending data to the slave or requesting data from it. The address frame includes a single bit at the end that informs the slave whether the master wants to write data to it or receive data from it. If the master wants to send data to the slave, in the sense, the read or write bit is a low voltage level. If the master is requesting data from the slave, in the sense, the bit is at a high voltage level. And coming to acknowledgement and non-acknowledgement bit, each frame in a message is followed by a acknowledgement or non-acknowledgement bit. If an address frame or a data frame was successfully received, an acknowledgement bit is written to the sender from the receiving device. And the data frame. After the master detects the acknowledgement bit from the slave, the first data frame is ready to be sent. So the data frame is always 8-bit long and sent with the MSB first. It is nothing but most significant bit first. So each data frame is immediately followed by an acknowledgement or non-acknowledgement bit to verify that the frame has been received successfully or not. The acknowledgement bit must be received by either the master or the slave. This is depending on who is sending the data before the next data frame can be sent. So after all of the data frames have been sent, the master can send a stop condition to the slave to halt the transmission. So the stop condition is the voltage transition from low to high on the serial data line after a low to high transition on the serial clock line, with the serial clock line remains high. So now let's see the steps of I2C data transmission. First, see here, the master sends the start condition to every connected slave just by switching the data line from high to low voltage level before switching the clock line. Then the master sends each slave the 7 or 10 bit address of the slave it wants to communicate with, along with the read and write bit. And then each slave compares the address sent from the master to its own address. If the address matches, the slave returns acknowledgement bit just by pulling the data line low for 1 bit. If the address from the master does not match the slave's own address, the slave leaves the data line high. It does nothing, like this. And then the master sends or receives the data frame. So after each data frame has been transferred, the receiving device returns another acknowledgement bit to the sender to acknowledge successful receipt of the frame. And finally, to stop the data transmission, the master sends the stop condition to the slave by switching serial clock line high before switching the data line. This is how I2C works. Here, single master with multiple slave. Because I2C uses addressing, multiple slaves can be controlled from a single master. With a 7-bit address, unique address are available. Using 10-bit addresses is uncommon. But also it provides a unique address. To connect multiple slaves to a single master, wire them like this. With a resistor, pull-up resistor connecting to the data and clock line to the VCC. And coming to multiple master with multiple slave, multiple masters can be connected to a single slave or multiple slave. The problem with multiple master in the same system comes when two masters try to send or receive data at the same time over the data line. So, to solve this problem, each master need to detect if the data line is low or high before transmitting a message. If the data line is low, this means that another master has control of the bus and the master should wait to send the message. If the serial data line is high, then it's safe to transmit the message. So to connect multiple masters to multiple slave, use the following diagram like this. Use pull-up resistor connecting to the data and clock line to the VCC. Now this is the advantages and disadvantages of I2C. The advantages are it only uses 2 wires like UART and it support multiple master and multiple slave. Unlike SPI only supports single master and multiple slave. And here acknowledgement bit gives confirmation that each frame is transferred successfully or not. And the hardware is less complicated than with UART. And it is a widely used protocol also. And the transmission speed is slower than SPI. When compared to SPI, the transmission speed is slow. And only the size of data frame is limited to only 8-bit. And this is more complicated hardware which is needed to implement than SPI. This is all about the advantages and disadvantages of I2C. So now, in this session we are going to use this module which is PCF857 for I2C LCD. We are not going to use the common 16x2 normal LCD. In this module we are going to use I2C LCD. There are many display devices like OLED display, 128x64 graphical display, and there are like Nokia 5110 display. But for displaying a simple text and a number, all we need is a 16x2 or 20x4 character display. So the main disadvantages of that display is it requires a lot of wires, lot of GPIO pins of a microcontroller to function properly, right? This is not even the 8-bit mode but reduced to 4-bit mode. Think about the 8-bit mode. So using that many pins of a microcontroller just for a simple character LCD display is not desirable, right? Especially if you are designing a project with lot of sensors and devices connected to the microcontroller, it took lot of GPIO pins. It will be like clumsy, right? So to overcome this drawback, we are going to use this module. As the name suggests, the PCF8574 I2C LCD module is IC based module designed to convert the regular 16x2 character LCD displays into I2C based devices, which means instead of using 8-bit or 4-bit parallel interface just to send the data, we can use this I2C bus to send data to the display. So this I2C LCD module includes the potentiometer to adjust the contrast of the LCD and pull-up resistor for serial data and serial clock line. So you don't need any additional connections for this. Just plug in the I2C LCD module at the back of this 16x2 LCD and make connections between the microcontroller and the I2C LCD module. Let me show you the module. So this is a 16x2 LCD, and in the back side we have to fix that I2C LCD module here, PCF8574. And we are going to only use these 4 pins: VCC pin, ground pin, data pin and clock pin. Only 4 pins. So now, the first thing we need to figure out for this I2C LCD interface to work is that I2C pins of this module. If you remember, in the ESP8266 pin out part, I mentioned that the ESP8266 microcontroller has 2 I2C interface. So here we will be using GPIO5 as clock pin, which is nothing but D1, and GPIO4 for data pin, which is nothing but D2. And another important point to note is that 16x2 LCD runs on a standard voltage between like 4.7 volt to 5.3 volt. We cannot apply 3.3 volt as VCC. You have to use this VIN pin to power up your 16x2 LCD. So keeping this in mind before interfacing your module. So now let's move to the software part, and before that, so this is the right time to switch your masterclass into internship. So let me tell you the benefits of this internship. You will get 30 days of live recorded sessions, and you will get 90 days access of the records, and you will get all the source code of the project we are used in this entire session, and you can also download all the presentations, and every week there is a mastermind session. You can clear your doubts and you can clear your queries with your mentor. And after registration, you will get your confirmation letter, and after that you will get your certification. And use this registration link to register, and use this coupon code to get the discount amount. This is only for 799. And these are the add-on project you will get in this internship. Smart street light using LDR and IR sensor. Monitoring soil moisturization using ASK sensor. Gas leakage detection using Arduino IoT cloud, IoT based heartbeat monitoring system, and BME 280 sensor readings to the real-time database, and web-based remote serial monitor, and sending email using SMTP, and also WhatsApp using what about API. So now we can move for the coding session. So before getting into the code, first we have to download one library called Liquid Crystal I2C.h library in order to work with I2C module. So search for Liquid Crystal.h library and go to this Arduino libraries info, and here you can download this zip file. I have already downloaded it. If you don't have, in the sense, just click on it and download, and go to sketch, include library, add zip library, go to the recent downloads and open that file. You can install your library into your Arduino IDE. So next what we have to do is, we need to find out the slave address of I2C LCD module. Since we are working with I2C interface, the slave address is one of the important things we need to be aware of. So here ESP8266 microcontroller is the master, and the PCF8574 I2C LCD module is the slave. To find the address, you can go for Google and search the code like how to find the slave address of that particular module in ESP8266, or otherwise just simply go to the file and go to examples. Here go for your liquid crystal library and click on this any one example project. First download the library and then you will get this example code. So here you can find out the address here. My module's address is 0x27. You can find it by like this, or you can go for a code in the Google and you can copy paste that code and you can find your slave address. So mine is 0x27. This is what I am going to use in my entire code. So here, first we are going to displaying a static text on the LCD. It is very simple. All you have to do is select where you want the characters to be displayed on the screen and then send the message to the display. So for that, first we have to include the library. So I am going to use #include liquid crystal I2C .h library. So this line includes this library which provides an interface for controlling LCD displays using I2C communication. Here, then we need to define our columns and rows. Ours is 16x2, right? 16 columns and 2 rows. We have to mention that. I am going to use integer LCD columns and I am going to give column is 16. And similarly LCD rows which is equal to 2. So this line defines two integer variables, LCD columns and LCD rows, which specify the number of columns and rows of the LCD displays respectively. So now we need to create an object. So using liquid crystal I2C class, I am going to create object called LCD. So inside as a parameter we have to pass three things. One is slave address which is 0x27, another one is column and another one is rows. So this line creates an object of the liquid crystal I2C class named LCD. So the constructor takes three arguments. One is address, another one is column and another one is rows. So inside void setup, first we have to initialize the LCD. For that I am going to use LCD.init, which is initialization, and then I am going to turn on the backlight of the LCD just by using LCD.backlight. It turns on the backlight of the LCD just by calling this method. And inside void loop, I am going to set the position using LCD.setCursor method. Inside I am going to pass the column and row. 0th column, 0th row. Here I am going to print a message like using LCD print. First I am going to print a message like hello. And then I am going to give a delay of 1 second. Now I am going to clear my screen using LCD.clear. So it clears the LCD display using this clear method. And I am going to set another position using LCD.setCursor in 0th column and first row. Here what I want to print is that this is pantech. So again I am going to give another delay of 1 second, and again I am going to clear my screen using LCD.clear method. So yeah, This loop continues indefinitely, displaying the hello message for 1 second, followed by the this is pantech message for 1 second, and then clearing the display before repeating the process. So now we have to connect this. The first pin is for ground and the second pin is for VCC, so we have to connect this with VN pin. And the third pin, which is for D2 data pin, and fourth pin is for clock pin D1. Sorry, LCD has powered up. Because of the brightness, I think the screen isn't visible properly. So now we have to upload this code into the controller. So let us upload the code first. Yes, Abdul, if you want to give like directly the column and row in the sense, you just can give like this also. Let me give a command of here. You can give like instead of LCD column, you can go for 16, and instead of rows, you can also go for 2. I am just mentioning here just for your reference. Instead of giving these 2 lines, you can directly go for this also. This is also fine. So here it's printing hello, this is pantech. I think it doesn't visible properly. Because of too much of brightness, I think it doesn't. Okay. Okay, let it be. Now we can move for the second code. So let me erase it all. So now we are going to write a code for displaying scrolling text on the LCD. So which is especially useful when you want to display messages longer than 16 characters. So the library comes with built-in functions that allows you to scroll the text. So for that, first we have to include the library, which is liquid crystal I2C.h, and again, if you want to mention the columns and rows in the sense, you can give like you can create a variable like this. Otherwise, you can just mention directly 16 or 2. If I switch off the light in the sense, that also you can't see this, I think. Because of the LCD brightness, it doesn't show the light properly. Okay, so here I'm going to give like LCD columns which is equal to 16 and int LCD rows which is equal to 2. So now we have to create object using liquid crystal I2C class. I'm going to create LCD. So inside we have to pass 0x27, which is our slave address, and I'm going to pass this column and rows. Let me copy this. Let me paste this here. So now we have to mention we have to create actually two string variables. One is for message static and another one is for message to scroll. Using string, first I'm going to create like message static. So here I'm going to print message like static message. And again I'm going to use string message to scroll. This is the message for which I'm going to scroll. So inside I'm going to give like this is the scrolling message with more than 16 characters. So these lines create two string variables named message static and message to scroll, which hold the static and scrolling message respectively. So now we have to create a function called void scroll text. I'm going to give a name like scroll text. So inside we have to pass four things. One is integer row. So the row number of the LCD display where the text will be scrolled. Yeah, thank you. Thank you, Kranti Kumar. Yeah. So next one is string message. The text message that will be scrolled on the LCD display. So I am going to give like string message. And third thing will be delay time. Integer delay time. So the time delay I am going to give not one, I am going to just give a millisecond between each step of the scroll. So the first thing is row, the second thing is the message, and the third thing is the delay, and the fourth one is integer LCD columns. So the number of columns on the LCD display. So inside I am going to add a for loop for spaces to the beginning of the message string so that the message starts outside the visible area of the LCD display. So inside I am going to give like integer I which is equal to 0 and again I which is lesser than LCD columns and then I increment. So inside I am going to give like message which is equal to, I am going to give a space and message. So after the loop, the message string will have additional spaces at the beginning. So making the total number of characters in message equal to the LCD column. This is done to ensure that the message starts outside the visible area of the LCD display. So by adding spaces, the text will scroll from right to left, gradually revealing the entire message. So again, I am going to give like another space, message, like this. So here I am going to add extra space at the end of the message string. This is for the beginning, this space is for beginning and this space is for end of the message. So this is to ensure that the message scrolls completely off the display, leaving no visible residue. So inside the function, it first adjusts the message string to ensure it has enough padding on the left and right sides to cover the entire display width. It adds spaces to the beginning of the message string until its length is equal to LCD columns. Then it appends a space to the end of the message string. So now I am going to add another for loop. This is the main loop which is responsible for scrolling the text on the LCD display. So I am going to use another for loop. So inside I am going to create one variable called position. I am going to initialize this with 0 and position which is lesser than, I am going to use a method called message dot length. So then position increment. So this line initializes a variable position to 0. So the loop will continue as long as position is less than the length of the message string. So the purpose of this loop is to scroll the text by moving the window of visible text through the message string one character at a time. So here inside I am going to give like LCD dot set cursor and I am going to give 0 comma row. 0 is nothing but column. So the column number is set to 0, which means that the text will be printed from the leftmost column of the specified row. And then LCD dot using print inside I am going to give like message dot substring. So inside I am going to pass position and position plus LCD columns. So in this line, it prints a substring of the message string starting from the current position and with the length of the LCD column. This effectively prints a portion of the message within the specified window size LCD columns. And then I am going to give a delay. Inside I am going to give like delay time, which we have mentioned here. So this function calls the delay of delay time millisecond between each step of the scroll, which is controlling the scrolling speed. So now we can move for void setup. So first we have to initialize the LED and then we have to turn on the backlight using backlight method. So that's all about setup. Then we can go for void loop and inside first I am going to set the cursor using LCD dot set cursor. I am going to give 0 through 0 column and I am going to print a message static. This will print the static message which will give this one, and now we have to print this message to scroll. So for that we have to use this function. So scroll text, inside we have to pass three things, right? Row, string message, delay time and column. So row is, I am going to print in a first row because in 0th row we are going to print the static message, which is static message this one, and in first row I am going to print this one. So second one is message to scroll. This one I am going to print, so let me copy this. And third one is delay, let me give 250 like, and at last LCD column. These are the things we have to pass inside the function. So that's all about the loop function. So now let me upload this to the microcontroller. Because of too much brightness, I think the output will not be shown properly. Still, let me try to show you. Day 11 attendance already have been posted in previous session. Day 11 attendance already have posted. Twelfth session itself, they have already posted the 11th day's attendance. So this is printing the message like this. I think because of the brightness, I think it doesn't show properly. So let me record it in a mobile phone and I will show you in the some other session the actual output of the LCD. So in some other session I will show you the outputs of event management system. We have not seen that output, right? So I will show you that output and previous class output, which is SPI communication between that thing. I will show you all the outputs in some other sessions. So now let me erase this again. Now we can move for next thing, which is displaying custom characters. So in a 16x2 LCD there are actually 32 blocks where you can display characters, which means each block is made out of 5x8 tiny pixels. You can display custom characters just by defining the state of each tiny pixel. For that you can create a byte variable to hold the state of each pixel. So let me show you first that we have to include crystal I2C.h library. In this code I will remove the LCD backlight and let me show you the actual output, okay? And then we have to give like we have to create the LCD columns, which is equal to 16, and integer LCD rows, which is equal to 2. Now we have to create object using LCD crystal I2C, and I'm going to create object name like LCD, and inside we have to pass address, LCD column and LCD rows. So here we have to create the custom character. So for that I am going to use byte array name. I am going to create a heart. Inside I am going to give 8 because there is 8 rows, right? So here we have to open the set brackets. Here we have to mention that bits. So for that I am going to use 0B. Remember that this is 5 cross 8 pixel, which means 5 columns and 8 rows. For that I am going to give like 0B. First I am going to give like 5 zeros. I will explain it, wait for a few minutes. And then 0B, I am going to give like 0, and then 0B. We have to create 5, 1, same thing for 3 times. And again 0B, 0, 111, 0, and again 0B, 00, 100, 5 zeros. So this is nothing but, see, the prefix 0B before a sequence of digits represent a binary literal. This notation is used to specify a value in binary, which is nothing but base 2. So each digit in a binary number can be either a 0 or a 1, representing the two possible states of a binary system. So this block of code defines a custom character named heart using the byte data type. The heart character is defined using a 5 cross 8 pixel grid where each bit represents a pixel. So the series of 0B followed by these binary numbers represents the rows of the character, with 1 indicating the filled pixel and 0 indicating the empty pixel. Here I am going to make a heart in 5 cross 8 pixel. If you want to create some other image in the sense, you have to give it accordingly. To fill that pixel, you have to give 1. To empty that pixel, you have to give 0. So now we can go for void setup. So inside void setup, we have to initialize LCD init, and here we don't have to give that LCD backlight. So now I am going to give LCD dot create character method. So inside I am going to give like 0 comma heart. So it creates a custom character by calling this create character method to the LCD object. The first argument 0 represents the character number, which comes from 0 to 7. And the second argument heart is the custom character pattern which we have defined earlier. So now we can go for void loop. So inside I am going to set cursor. I am going to give like let's give 5th column or 0th row. And then we have to use LCD dot write. Inside we have to pass that character number, which is 0. We have mentioned here, right? So this is all about our code. So now let me open this and let us upload this code. It's uploading. Yeah, see, here you can see the output, right? This is the heart symbol actually. So this is our output. Here I am creating an array. I am given the 8 inside the parameters. So inside this we are using 5 cross 8 pixels, right? This means 5 column and 8 rows. So that's why we are using like this. So the prefix 0B is nothing but is a binary value, which means base 2 format. So each digit in a binary number can be either 1 or 0, representing the two possible state of a binary system. If you want to fill that pixel, in the sense you can give 1. If you want to empty that pixel, in the sense you can give 0. So here I am going to show a heart symbol. That's why according to that heart I made zeros and ones. If you want to show some other picture, in the sense you have to change that accordingly. So that's all about this byte heart. And let me also show you the before program. Just a minute. So let us include this. Let me command this LCD backlight and let me upload this. Before that, select the board and its port. So now let us upload this and let's see. Yeah. So here we are just going to print hello, this is pantech, right? Attendance I have already provided, please go and check. They pin the attendance. See, hello, and in second row it will print like this is pantech. Are you able to see this? Are you able to see this? In first row it will print like a hello, and in second row it will print like this is pantech. And scrolling text we will see. Look at this. Are you able to see this now? Are you able to see this now? Hello in the first row and this is pantech in the second row. And now let me upload the scrolling text. Let us see. Yeah. Okay, in tomorrow's session or some other session, I will also show you the output of event management using that RFID, and also we will see the output of SPI communication. We have to get that hello slave message from master to the slave, right? I will show you the two outputs in some other sessions. Sorry for the previous classes, it doesn't work properly, that's why I can't show the output. I will definitely show you in some other sessions. Actually make a record of that RFID video. My model doesn't work properly, so I capture a video of that. I will show you in some other session, and also we will again connect the Arduino board and the SPI8266 board. We will see the output of that master slave code also. So sorry, here I forgot to command the LCD backlight. Let me upload it again. Yeah, it's uploading. Few seconds. Uploading. See, in first row it will print a message like static message, and in the second row it will print the scrolling text that we have mentioned in the program, which is this is a scrolling message with more than 16 characters. It's running. Are you able to see static message in the first row and the scrolling text in the second row? Is this visible to you? So that's all about the today's session. Let's catch up at the different topic at tomorrow's class. So thank you all. Have a very nice day.